Hey everyone, in Chemistry 40S and Chemistry 40SH, Dr. Carroll here. Today we're going to do a quick review for Friday, the March 27th test. So that'll drop early Friday morning, and then you'll have, let's give you that day, and you might as well take the whole spring break. So it's due Monday, April the 6th at 5 p.m. So that gives you the whole day, the whole break. So you're going to do an excellent job on it, and you'll have, for this one, you'll have your notes to help you. Let's go over some things that will be on it. So first of all, there's going to be this is Chem. Oh, look at this. Look what I got here. I got a fancy tablet here. Take 2 tablets and call me in the morning. Chem40S, Chem40SH, Unit 3, Kinetics review. Somebody's saying, oh, why don't you print all this out, type it all out, and just read it? Because it's fun to write it, and you'll pay more attention, right? It's more simulating the actual environment, which is always fantastic. So, well, let's see. There'll be 20 multiple choice questions. There are some, in your booklet, some sample multiple choice questions for you to do. And, of course, that turnip review is helpful. And then there'll be 30 points for written responses. And so, what did we look at? We looked at just the definition of rates. Sometimes we get those horizontal lines just appear. And rate just being the change in concentration of something with respect to time. And if you want to be fancy, you can use absolute value. So that's one thing that we looked at. I just have my booklet with me, and I'm just looking at some of the things. We looked at factors affecting rates. We get these vertical lines every now and then. Factors affecting or effecting? Affecting. Oh, affecting rates. Okay, I'm squeezing down on something that's not so good on the pen, but we're getting it. So what do we have here? Things like surface area. There, that's better, right? Right, you smush something up into a finer powder, you get more effective collisions. If you dissolve a sugar cube, it takes longer than to dissolve just powdered sugar, because powdered sugar has a greater surface area. We looked at the nature of the reactants. Are there more bonds that have to be broken in the same phase? So let's control our variables. The more bonds that have to be broken and rearranged, the longer the reaction takes. The more time it takes, the slower is the rate. So we also looked a bit at phases associated with that. Gases and aqueous are faster than solids and liquids. So that was the first 3 pages. We looked at temperature changes. Okay, temperature goes up, the rate of the reaction goes up. Also, we looked a little later in the chapter, the rate constant also increases. And you should understand what those curves mean in terms of kinetic energy distributions versus temperature. And this could be my threshold energy, which is also called the activation energy. So this could be T1. But if I go to a higher temperature, then we could have T2. And T2, we're going to have more effective collisions. So further doubling, you can double the rate if you increase the temperature by 10 degrees Celsius. That's a rough idea, but that works okay. So let's say you had a rate which is, let's say 0.03 moles per liter per second at 40 degrees Celsius. Then at 60 degrees Celsius, it would be 0.06, 0.12, right? You just double it. Moles per liter per second. Okay, let me try to now go to a new page here. Let me turn the page. New. Okay, I want to get a wider pixel range here. So maintain the aspect ratio. That keeps it as a rectangle. We're just learning on the fly here. So I'm going to go up to, oh, let's see, 11-inch. You think that'll over? I'm using a laptop computer here, so a little bit of math on the fly here, but that makes it fun. Oh, 11.01 inch. Oh my goodness. Oh no, 11. Okay, okay. Yeah, that made it a bit bigger. Okay, so let's see what we have here. Just looking through. Now I'm going to changes in concentration. So the rate is proportional to the concentration of the reactants in the rate determining step. Now, when we first talked about this in the chapter, in the booklet on page 5, we just said, oh, the more reactants there are, the more effective collisions. But you got to be a bit more careful with that. And it's changing the reactant concentrations in the rate determining step that affects the rate of the reaction. So if the reaction is first order with respect to A, if I double the concentration of A, I'm going to double the rate of the reaction. If it's zero order with respect to Q, then if I double the concentration of Q, I don't do anything to the rate. Okay? Then we looked a bit at catalysts. Catalyst, right? They speed up the rate of the reaction without being seen in the overall reaction. They are seen in the intermediate steps. Oh, I shouldn't say intermediate steps. Sorry. They're seen in the elementary steps that make up the reaction mechanism. And you decide to put a catalyst in. And you first see it on the left-hand side, and then later on, it's on the right-hand side. The catalyst lowers the activation energy, right? We looked at these potential energy profiles, of which you're going to have to be able to draw one. So here's an exothermic one. This is catalyzed. Sorry, it's not catalyzed. And oh, watch this. Watch this. You're going to be impressed here. If I can pull this one off. Let's go here. And oh, look at that. Look at that. There you go. See, the uncatalyzed one is in purple. Now, you think I can go back to the black one? Oh, now I'm stuck in purple. Okay, well, that's fine. Gotta jazz it up a bit. Oh, now I've gone to blue. Okay, so the catalyzed one was purple. This is my potential energy diagram, kilojoules along the y-axis, and then reaction pathway or progress of reaction, reaction coordinate are all common terms for my x-axis, also known as my abscissa, if you want to show off. Then pressure changes. Well, increasing the pressure is increasing the concentration if we decrease the volume. And that was shown on page 7. Then we talk about rates, changing concentration with change in time. And let's make up an example here. I'll get my calculator. Let's say we're going from A to Z. Okay, and you started with 5 moles per liter of A, and you ended with 2 moles per liter of A, and you timed it for 3 minutes. So then your rate would be the absolute value of the change in concentration of A with respect to time, so 2 minus 5. With respect to time, let's make it in seconds, 180. So that's going to be 3 out of 180, which is 1 out of 60, which is 0.017, rounding, moles per liter per second. So that is a way to calculate the rate, and we'll use that as our average rate. Then we got talking about collision theory, and we had, here I'm looking at page 13. We talked about effective versus ineffective collisions. Effective collisions are ones that have the chance to form product. They get you to the activated complex. Remember, the activated complex isn't an energy, it is a collection of colliding particles, some of which are going to form product. So you need, to get to the activated complex, you need enough energy, at least activation energy worth of energy, and the proper orientation. So effective collisions, you need energy. Effective collisions, you need activation energy and proper angles of attack, proper orientation. And we drew some drawings about that on page 13 and a bit on 14 and on 15. Okay, and then we talked about the potential energy diagrams. I'm going to open a new page here. File, new. I guess I could have paused the recording, got to the new page, but isn't it fun to see me struggle to get the new page? 11.33 inches. Was that going to be? Oh, that looked bigger still. Okay, we're going to have some fun with this. Okay, so potential energy profiles. There's two equations that you got to know. Delta H reaction is potential energy of the products, the devil wears product, minus potential energy of reactants. Why does that horizontal line appear? And we can also write delta H reaction is EA forward, not EA sports, EA forward minus EA reverse. Okay, so you're going to have to draw, you're going to have to label. Here's a exothermic case, there's my reactants, there's my products, there's my activated complex, there's my forward activation energy, there's my reverse activation energy, and there's my potential energy in kilojoules versus, and on my right hand side I got to do progress of reaction. Endothermic, your products are higher up than your reactants. Okay, and you've done lots of practice. I'm not going to do one here. You have them in your notes there. And page 20, page 21. And not only will you have to draw them, but you'll have to interpret them. Like I can give you a potential energy diagram and then you read off it and get the answer. For example, question 7 through 10 on page 25. Page 25, 7 through 10, examples of those. Okay, so what else do you got to know? The reaction mechanisms. Series of elementary steps that together give you the overall reaction. And so you have to know the difference between a simple reaction and a complex reaction. You have to know your RPIC charts, reactant, product, intermediate, and catalysts. And have to add together your elementary steps to give the overall reaction. So you have to be able to do that. One thing I should have said off the side, catalysts. Remember with catalysts you have to know the difference between homogeneous and heterogeneous catalysis. So know those differences. Homogeneous catalyst, the reactants are in the same phase as each other, and also the catalyst is in the same phase as the reactants. For heterogeneous catalyst, the catalyst is in a different phase than the reactants. We don't care about the phase of the products in that definition. Okay, you should know the difference between intermediates and catalysts, right? Intermediates first appear on the right-hand side. You don't create them. They're created by the reaction. And then later on, the intermediates are consumed on the left-hand side. Whereas, that's my word of the day. Well, I'm going to put that in a different color. Whereas, you decide to put in the catalyst. So it first appears on the left-hand side, but then is regenerated on the right-hand side, so it can do more damage. And the similarities between an intermediate and a catalyst is that neither appears in the overall reaction. And you can have more than one intermediate. You can even have more than one catalyst. We don't find that often, but you often can find more than one intermediate in a reaction. We talked about the rate determining step. Okay, I mentioned that even earlier in the review. The slowest step in the reaction mechanism. It's not necessarily the first step, but wherever it is, it's the slowest step in the reaction, and the concentration of the reactants depend on the rate of the reaction overall depends on the concentration of the reactants and the rate determining step. And so that gave us the final topic, which was the rate loss. You could have like rate equals K, A to the M, B to the N, C to the P, etc. And the order of the reaction overall, you just add the exponents together. Oh, do I have a little arrow here? No, that just moves the whole thing. I must have a pointy arrow here to do that. What's that thing? Recolor. No, I don't want to do that. Okay, I'll just go back to the paintbrush. There. Oh, there's my arrow. So M, I'm making it as I go. M, N, and P are all orders with respect to A, B, and C. So the overall order, you just sum together M, N, and P. So if M was 1 and I doubled A, then I double the rate. If M was 2 and I didn't change these around and I doubled the concentration of A, then the rate would go up 4 times. Okay, let's get a new page here. Let's go to 11.33 inches for my width. And the final topic was all about those charts, like on page 34 to 40. That's my quantitative rate questions, where you solve for K, solve for M, N, and remember the units of K are different depending on the order of the reaction. So there will be some definitions you have to know, like all the stuff we've said, right? Reaction mechanism, elementary steps, effective collisions, and ineffective collisions. Fine, I won't write all this stuff down. Activated complex, activation energy, just the definition of a rate, change of something with respect to time, order of a reaction, heterogeneous versus homogeneous catalyst, catalyst versus intermediates, catalyst versus intermediates. Sounds like a new movie in the Fast and Furious chain, doesn't it? Quantitative rate laws, all that good stuff. So lots of stuff, but I'm confident you can do it. When you submit the test, please send it as an email. Don't send it back to me through Edsby. That isn't as smooth. So, I mean, we'll use Edsby for a lot, but for submissions of assignments and tests, send me as an attachment icvmcmtc@gmail.com. Okay? And use Microsoft Lens or equivalent or like if you take 6 pages pictures and send me 6 pages, I don't want that. Put them into a Word file, put them into some other file, make them into a PDF, and then send it to me. Okay? Yeah, I know it takes you a few more minutes, but otherwise I'm going to get grumpy and I'm going to just start getting capital grumpy. So just send it as a PDF file. That's why that Lens program is good, because it lets you add each page in and save it as a PDF. Now, it is available for Android through the Google Play Store, in addition through the iPhone App Store. So please get that program and use it. So for multiple choice part of the test, just create a sheet of paper, go to a pulp and paper mill and create a sheet of paper and just number your questions and then your answers. A, B. Oops, are those the right answers? Oh no. Don't circle them on the test sheet and hand back the whole sheet. That's just a pain in the neck. For the written responses, yeah, those ones, please print neatly, take pictures of them, bundle them into a PDF. So what I'll get emailed back from each of you is just one file that has the multiple choice on one sheet of paper, and then subsequently the completed written responses on a stack of paper, all within one file. I think I've belabored that point by now. Okay, so I hope this review was helpful. Of course, on our website, tinyurl.com/vmchem, there are videos from Brightstorm and Tyler DeWitt, who looks like Justin Bieber, and others, Khan Academy, if you really want to look at, so you can get additional help with all that. Bon chance!